We've done integrals, double integrals over rectangles, but what if it's not a rectangle? What if it's something weird like this? Well, there's two possibilities. We can either cut it up x then y or y then x. Let's look at the possibilities. Let's say I've got this region D, and I can describe the top border and the bottom border using nice pretty functions. Y equals g of x, g1 of x of g2 of x. Then I'll integrate with respect to y first and go from g1 to g2, and then I'll go with respect to x, going from a to b. So let's look at an example. Suppose I want something nice and simple. I have f of x equals 3x plus 2y, just a nice plane. The region I care about is x squared plus y squared is less than or equal to 4, so a circle, but x and y are both positive or equal to 0. So that means I'm looking at this quarter circle here. I think it's easiest to chop it up this way, and then I will solve for y, so I get the function in terms of x. So I'll be integrating from 0 to square root of 4 minus x squared, and x goes from 0 to 2. So let's set up the integral. We have this. It's kind of crowded up there. It's okay. We're going to integrate with respect to y first. So I have 3xy plus y squared, and my y is going from 0 to the square root of 4 minus x squared. Let's plug and chug. I get this expression, integral from 0 to 2 of 3x square root of 4 minus x squared plus 4 minus x squared. Now this part is pretty easy, but this part we're going to need to use a substitution. So I'm actually I figure you might be a little rusty on this, so we're going to do this off on the side. So let's go to the next slide. If I do this by substitution, I'm going to let u equal 4 minus x squared, so du is negative 2x dx. That means my 3x square root of 4 minus x squared dx becomes negative 3/2 integral of u to the 1/2. Integrating that and simplifying and plugging back in. So that goes right there. Integrating, I get this, plus 4x minus 1/3 x cubed. I plug in the 2, then I plug in the 0. I get this mess. I simplify, I get 40/3. Let's look at another example. Suppose this time I want 3x squared plus 2y squared be the function. It looks like this, a little curvier. The region I care about is the region between the x-axis and the function y equals x squared. And that looks like this. Still looks like I want to chop it up vertically. So I'm going to go from x squared minus 1 to 0 for my y's, and my x's will go from negative 1 to 1. First I integrate with respect to y on the inside. So I get 3x squared y plus 2/3 y cubed, going from x squared minus 1 to 0. Then I plug in and simplify a little bit. At this point I have to say I was trying to be fancy. I tried to figure out how to integrate x squared minus 1 cubed using a trig sub or something cutesy, and then I just said, screw it. I'm just going to multiply that sucker out. And then I can do a nice normal power rules, gross fractions, but hey, they're just fractions. Plug and chug, get 148 over 105. What if we want to chop it up the other way? Well, same idea. I can write the left border as a function g1 of y and the right side as a function g2 of y, and my y clearly goes from c to d. Same idea, I just switch the order. I'll integrate with respect to x first and then with respect to y. Let's look at an example of that. Okay, now let's look at f of xy equals xy. Here's a sketch of it, or a graphic of it rather. The region I care about is bounded by y equals x minus 1 and y squared equals 2x plus 6. Both of these equations look like they're much easier to solve for x than y, so I'm going to do this sideways version, the other version. Quick drawing of the region, we get this. It looks like my y goes from negative 2 to 4, and my x is going to go from 1/2 y squared minus 3 to y plus 1. Setting my integral, I get this. Integrating with respect to x first, I'll get x squared over 2 times y, with x going from 1/2 y squared minus 3 to y plus 1. Plug that in, and I get this mess. And again, instead of trying to do something cutesy, I'm just going to multiply it out. So then I can do the power rule, plug in my 4, then subtract off plugging in the negative 2, and I'll get 36. So what's our takeaway? The first thing you want to do is decide which way it is easier to chop up. You want to write up the boundaries appropriately and then integrate. It's a bit gross, but not really hard, and actually it's can be a lot gross. I want to work more on what the boundaries would be and how to integrate rather than killing you on some gross integrals. But we'll see. I can be a bit of a bitch sometimes, so maybe you'll have some ugly integrals too.